Okay, so I'm going to walk you through how to solve the ionic compounds in our ionic compounds worksheet. Now, for some of you, that's a long list in a Word doc. For some of you, that's this tiny little slip of paper that has chemical formulas on it. But either way, you have the same assignment. Question number one. The assignment is to figure out what the chemical formula is if I combine these two compounds. One is a metal, one is a non-metal. That means it's going to be ionic. So when I look at my periodic table, I can find aluminum right here, number 13, and I'm combining it with bromine, number 35, right there. So um, the first step is to figure out how many valence electrons each one of these two atoms have, because that's going to tell us their charges as they turn into ions. So for aluminum, I go to the periodic table and I see that it's a number 13 and it's in group 3. That means that it has 3 valence electrons. Since it's number 13, I know it has 13 protons with positive charges and 13 electrons with negative charges. I take the electrons and I put them into the orbits like we've done. My first shell holds 2 seats, so I have 2 electrons in that one. And I can fit 8 in the second row, giving me a total of 10. I have 3 more. Those are going to go in the third row. And that gives me 3 valence electrons in that final row. Now, in order to solve a full shell, that means aluminum will either have to gain 5 or lose 3. Since it's a metal, it's going to lose the 3. Metals have very low electronegativity. They're not very good at holding on to their electrons. So this aluminum is going to give up those 3 electrons. If we wanted to draw it as a Lewis dot diagram, it would look like this, with 1, 2, and 3 valence electrons. Bromine is in group 7, number 35. It has 7 valence electrons. 1, 2, 3, 4, 5, 6, and 7 valence electrons. Notice that bromine only needs 1 more to complete its octet, to get its full set of 8 electrons in that outer shell. Aluminum has 3 to give up. So what happens is that aluminum, given its low electronegativity, is going to ditch these 3 valence electrons here, and they're going to go out into solution. They will be loose and free floating electrons, just sitting out to be used. If I look at my shells, you'll see that by losing those 3 electrons, this shell is empty. It no longer counts. It's not important anymore. My second shell is full. So when aluminum loses those 3, it satisfies its octet rule. But it means that it goes from having 13 electrons to now only having 10 electrons. Now, that means I have 13 positive charges and 10 negative charges. They are no longer in balance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 protons, and 10, 6, 7, 8, 9, 10 electrons. Now, these will cancel each other out. All of these forces here will cancel each other out, but I'm left with 3 positive charges that don't have a negative charge to bond to. And so that means that aluminum is now an ion. It has an overall positive charge of 3, and I write that as 3 plus. So this aluminum is no longer a neutral atom. In the past, the atomic number has told me the number of protons and electrons, and they were always balanced, so everything was neutral. But that's not the case anymore. Now my aluminum has an overall positive charge because it's lost those electrons. Bromine can only fit 1 more electron. It has 35 electrons. and 35 protons. So I'm not going to draw this whole thing again, but it's going to pick up one of those 3 electrons that have been lost. And that'll complete its outer shell. Now, bromine has 1 more electron than it had before. So bromine, number 35, had protons 35 protons. Now it has an extra electron. So it has 36 electrons. Now, with 36 electrons and 35 protons, that means that this has an overall charge of -1. Because now, the opposite of aluminum, where it lost electrons, bromine gained electrons. That means that bromine now has a negative charge. And so when I write that as an ion, I'm going to call it bromine 1 minus. Or I could even just say bromine minus. Now, that just gets me set up to answer my question, what is the chemical formula? If aluminum has a 3 plus charge on it and bromine has a -1 charge on it, then I need to know how many bromine will balance out this aluminum. So if aluminum has a 3 plus charge, it needs to bond with 3 negative charges in order to balance out the whole compound, which means for every aluminum, I'm going to need 3 bromine. And so that's the solution to my first problem. Aluminum bromide 3, AlBr3. Hopefully that helps. I've also included some other YouTube videos in this slideshow, so you can look at those if those might help. And you can always reach out to me again, email me at any point, come into my open the lab hours after class, whatever, and I can walk you through this again. But hopefully this helps.